So we are treating the topic queer item, right? Okay. So we are having three boxes, and this is our official software for Siemens PLC, and we are having a counter normally closed and normally open, and this is what we do here. I put a normally closed contact. Yeah, that's a normally closed contact. For the exit sensor is an inductive um, proximity sensor, and I latch the entry conveyor with this normally open contact here, which whenever the entry conveyor starts, even despite the fact that the exit sensor loses signal, the conveyor will still be running, so that we can have our first conveyor to keep running while the emitter emits those boxes. So this is our counter. We have CTU, and this is our CPU, which is our virtual PLC. This is our virtual PLC, and here we virtually put on the first signal and the second signal. I mean, for the two sensor, we virtually close and open them. All right. So let's see what happened to the programming from the start. Now the sensor is a normally closed sensor, and that means when signal comes in, the normally closed contact here we open, but this entry conveyor, the latching um, branch, we latch the entry conveyor, so the conveyor will keep rolling. You can see it's green. It will keep rolling and keep rolling for the box to stack each other at the end of the first conveyor, and we have our first conveyor rolling. So the moment I click on that address here and I open the signal, it's a normally closed contact, so I open the sensor. You see we have a signal coming in into the conveyor, but irrespective of that signal, whether it goes off or on, our entry conveyors keep moving. You understand? So that's what we want to achieve. They want to achieve that whether irrespective of the state of the signal, the entry conveyor should keep moving. So on the counter, each time we have close or open signal from the input sensor, on the counter will keep rising. It will keep counting from 1, 2, 3, and once it is 4, then the second conveyor will start. So this is what we have here, the address 1. So once I put it off and I put it on, the address 2 rather, you see the counter is moving right now. Keep watching the counter and you can see what happened to the buffer conveyor, which is the second conveyor. And how will you reset this conveyor? By the time the sensor 1 comes in, and it will reset back to 0. Our counter will reset back to 0, and you keep the box all over and all over again. So this is just a clue on the Q item. I know you must have tried, and programming is a very dynamic thing. You can have your own in another style, another way, but just for you to have a clue for those that did not get the um the the way to go about it and around it. So join us in the next exercise. Thank you all.